So, Chapter 3 is all about project management. And first of all, projects represent a special type of network. They typically are very complex networks. Typically, you do them once. And so, as an example, it could be, a new product rollout. It could be a new marketing campaign. It could be a new product of some sort or a service, that kind of thing. The second thing about them is that a lot, when you're working in management in the business world, typically nobody gives you a list of all the things that need to be done. That's usually what they hire you for. And so in order to find out what are all the things that need to be done, there's something called a work breakdown structure. And work breakdown structures, just think of them as a list of everything that needs to be done in some sort of a sequential list. All right, and typically when a project team is formed, the project manager will have like a brainstorming session with their entire team, and then they'll use like those little sticky notes to generate not only all the tasks and activities that all the members think need to be done, but they'll try to put them in some sort of a sequence and then estimate how long it'll take, etc. And so that's basically what a work breakdown structure is. The book provides us with all the activities and the sequencing and everything like that. So we don't have to worry about that to do the homework. However, I did want to mention it since it is something that, from a practical perspective, is important. We're going to represent projects with networks, and networks are like processes. They have nodes and arcs, and so we're going to use the activity on node representation of our networks. So each node or circle will represent an activity that needs to be done. And then the arrows or the arcs will indicate the order that the activities need to be done. We won't really need to worry about dummy activities because we're not going to be dealing with activity on arrows, and that's pretty much something that is specific to that type of convention. So I wouldn't worry about that fourth bullet point. The critical path is the longest path through a network. Longest being the total amount of time is the longest. And so we're interested in the critical path because that's going to dictate how quickly the project can be completed. So to complete the project, you have to complete all the activities in the network, and the longest path through all the activities is called the critical path. And then the last thing that we're going to talk about this evening is something called crashing. And in a project management perspective, crashing is shortening the overall length of a project by allocating extra resources to it. Okay, so any question? This is kind of more of an overview slide, but any question on the slide or anything that I covered? Okay, so there are 6 skill sets to be mastered in Chapter 3, and I've identified them, and we're going to actually practice all 6 of them. Well, we're going to practice 5 of them. I'll give you an example of the third one, the work breakdown structure. But the first one is, the first 2 are what I would call drawing a network and just doing basic analysis. And so drawing a network diagram and then identifying the path durations, critical path, and all that, that is what I would call project analysis. The third and fourth one are more interesting from a practical standpoint. The fifth one is we are going to move from a deterministic model in terms of assuming that all of our activity times are fixed and don't vary. And in number 5 there, we're going to assume that they do vary and they are distributed in a bell-shaped curve. And so we're going to actually deal with probabilistic activity times. And then the last skill set is to, construct a crashing table and try to optimize the amount of crash time that's needed. And that'll either be given in the problem or you'll have to find what the optimum crash length is. Okay, so again, what we're going to talk about this evening are outlined in those 6 items there. And if you understand those 6 items, you should be able to do the homework without any issues. Knock on wood. So any questions on this slide? Okay, so let's talk about, let's do an example here. And let's say that there's a student, Chris, who received new word processing software for her birthday. And she also received some money with which she plans to buy a new PC. Chris plans to use the new software and the new PC to write a paper that's due next week. And so Chris has actually made life easy for you guys. She's identified all the activities and how long it'll take each one, and as well as the sequence. So, for instance, activity A is shopping for a new computer, and there is no immediate predecessor. That's what the IP stands for. There's no immediate predecessor to A. And so A is going to, start the network. That's the first thing she's going to do, and she estimates that it's going to take 2 hours. Okay, so using this example, okay, let's go to the next slide. What we can do is we can identify and do like a work breakdown structure. That's what WBS is, where WBS identifies kind of the key themes that you can group all the activities in. And one of the themes is activities related to the PC. So that would include shopping for it, buying it, installing the software. And then the other theme is the paper. And so the activities around doing the paper would be, searching a topic, doing an outline, writing it, and doing a grammar check, and then submitting it. Okay, so again, this is an example of a work breakdown structure. So if you didn't have the slide, the previous slide, and if Chris hadn't, identified all those activities and the amount of time, what she probably would do is, generate a work breakdown structure like this, and then, okay, these are all the activities. I have activities associated with the PC and activities associated with the paper. How long are each of these going to take, and how do they relate to one another, sequentially? Okay, so this is an example of a work breakdown structure. Any questions or comments on this? Okay, so let's see if we can draw the network. All right, so this is sort of trial and error. So what you would do is you would look for any tasks that do not have an immediate predecessor. And the 2 tasks that do not have an immediate predecessor are task A and task D. All right, so the first tasks I'm going to put here are A and D. And you can see, task A has no immediate predecessor, and task D has nothing before it. Okay, the immediate predecessor to task B is task A. So task B follows task A. All right, and so we would put B here. And then C comes after B. All right, so then I would draw an arrow here, and I'd put a circle, and I draw. Okay, and then after D comes E. So again, then I'm going to come down here, and then I'm going to draw an E. And it's kind of a sloppy looking E, my apologies. And then after the E, D follows E. I'm sorry, E follows D. And then F follows C and E. So what I'm going to do here is I'm going to draw an F here, and then I'm going to draw arrows from C and E into F. And then G follows F, and then H follows G. All right, so this is an example of how you would draw a network diagram when you're given a chart that indicates, the activities in the immediate predecessors. Okay, so any questions on how to, read a table and draw a network when you're given immediate predecessors? Okay, so the second thing there, it wants you to identify all the paths. So to do this, you just work along the arrows until you identify each unique path. So the first one, the north route there, is A, B, C, F, G, H. And then the southern route there is D, E, F, G, H. Okay? And so once we identify the paths, then you can identify the durations. And the durations are just going to be the sum of the times for the path activity. So for the first path, activity A is 2 hours, activity B is 1 hour, activity C is 0.8, and then activity F is 3 hours, activity G is 0.5 hours, and activity H is 0.2 hours. And so if you add up all those times, let's see, you get 3, 3.8, 6.8, 7.5 hours for the first, that northern path, A, B, C, F, G, H. And then for the southern path, again, you're going to just add up the time. So activity D is going to be 2. Activity E is going to be 0.4. Activity F is 3. And then G is 0.5. And then H is 0.2. All right, so if you add all those up, you get 5, 5.9, looks like 6.1 hours. And I hope I did the math right there. Let me know if I didn't. So 6.1 hours. All right, so when you look at how long it's going to take to get the entire network done, it's going to take 7.5 hours. And so the critical path is the longest path. And so in this particular case, the critical path is A, B, C, F, G, H. And we expect that it's going to take Chris 7.5 hours. I mean, if she worked from start to finish to get everything done, it would take her 7.5 hours. All right? So any questions on how to, once you identify the path, how to find the path duration and the critical path, etc. Okay. So once you have, your paths identified and how long it takes to get each one, then what you can do is you can put together a schedule. Now, so let me come back here. Well, I don't have my network drawn here, but for instance, activity B, so activity B here, if you recall, we could do activity B only after we finished activity A. So if we, finish activity A on 11/9, let's say in the morning, then we can start activity B on 11/9 in the afternoon. Okay. So again, once you put together your network, then you can actually put together when you think you're going to be able to start each task and when you'll estimate to end it. You can also assign resources, and this is what a project manager would actually put together, that would coordinate activities and then be able to monitor the progress of the completion of the activities in the network. Okay, and I have shown the critical activities with an asterisk there. And the reason those are asterisk is again, if those slip, if those take longer, or if something happens that prevents you from getting them done in the estimated time that you planned, it's going to delay the overall project. Okay, so that is why they're asterisk. It's just to call attention to making sure that those are managed and to have contingency plans available in case they run over or they don't get done in time. So questions on the schedule? Okay, so this is problem 3.3 from the book. And you can see I have immediate predecessors. I have the time for each activity. And you can see I've drawn the network, and there are 3 paths through this network. And they're identified, and the critical path is the lowermost path, ACFH. It's 21 days long. And I also have here path slack. So what path slack is, it's just the amount of slippage that a path can have before it too becomes a critical path. So the path slack is going to be equal to the critical path minus the length of the path. So by definition, the critical path has 0 slack, because in this case, it's going to be 21 minus 21. For the first 2 paths, the path slack is the 21 critical path minus their duration of 19. And so you get a 2-day slippage that the path can slip by 2 days without it really affecting the overall duration of the project. Okay, so questions on this example?